Okay, today we are going to do a turbine valve transfer and sync the generator online. What happens during the valve transfer? Right now we're running on a pilot valve that's inside the trip valve. So we're admitting a small amount of steam into the turbine to bring it up to speed. All the governor valves, all 8 of them are 100% open. So we're controlling on the 2 pilot valves in the trip valves. We're sitting at 3450 megawatts RPM. Our valve transfer is required 492 degrees. We're 513, so we're plenty warm to swap the valves. On this screen, we're showing our throttle pressure, 637, steam temperature, about 617. You want to be about 6 and 6, so these are pretty good for rolling the turbine. Need about 100 degrees superheat on the steam. On this screen we have one pulverizer running, feeding 20,000 pounds an hour. This is what's heating up the boiler and rolling the turbine. We have another pulverizer that's aired up and ready to go. We'll have to have 2 pulverizers running when we go online. We'll have to get to 16 megawatts within 2 minutes to maintain steam flow through the turbine and keep from motoring the generator. So for the transfer, we're in the digital electro hydraulic screen. This is what is running the steam turbine. Go down to valve mode. Initiate the valve transfer. Shows transfer in progress. The governor valves are going to close down until the speed drops 50 RPMs. At that point, the governor valves are in control of the turbine, and then the trip valves can go full open. That way we'll be running on the governor valve control at that point. Then we'll go up to 3600 RPM. Right now we're running with 1 valve controlling the feed water, boiler drum level. Usually we use the speed on the feed pumps. We have a valve we use for startup. You can see the valves are still pinching down. Speed really hasn't started dropping yet. We'll have to, as soon as the speed drops a little bit more, we'll go ahead and put a pulverizer on. The trick is to get the pressure turning on the boiler start coming up right when we sync online. That way we'll have plenty of steam to get to 16 megawatts. The RPMs are starting to drop. See the governor valves are holding, and now the trip valves are starting to open. They should open up fairly quickly once the speed criteria is satisfied. Okay, trip valves are opening up. After a prolonged outage, you do a trip test, make sure all the trip valves work. These are the Reheat intercept valves. These come into play if you have a load rejection. They'll open and close really quick. Try and hold down the turbine speed. These are Reheat stop valves. Usually every 2 weeks we'll test the valves, make sure they move. Everything's functional. Last thing you want is a valve to hang up during a turbine trip. Okay, the valve transfer should be complete here. We're going to go to a pulverizer. Put all the igniters in. We had 2 backed out, just trying to hold the pressure. Have to have igniter for every burner, so you have to have 4 igniters running. Okay, we have airflow. The pulverizer is basically aired up and ready to go. We're going to start it once we get the permissive. Has to see the igniters burning before it'll let the permissive go. Okay, we have a start ready. Start the pulverizer. It's pulling about 75 amps. Motor starting current. Got 7,200 volt motor, about 800 horsepower. Start bringing a little bit more air up on it. We have to be above 29 in order for the feeder to start. Have to move the air kind of slow. There's only one other pulverizer running, so the primary air fans, you can get them to swing pretty easily. Okay, our DEH screen. Valve transfer is complete. We're going to bring the speed up to 3,600 RPMs. That's our speed we'll sync at. Probably run 100 a minute. Seem to have a little problem with the controls. Okay, there it goes. Okay, we're going to start coming to 3,600. This will be controlled on the governor valves. While it's coming up, we'll take a look at the turbine vibrations, burning metal temperatures, and the rotor position. This is the expansion of the rotor as compared to the casing. These are your thrust burning temperatures. This will tell you the loading on the machine. Starting up, you're heating the turbine up. The rotor will heat faster as it's smaller metal mass than the casing. So you don't want it to grow too fast, or the blades can hit the diaphragms and do damage internally. So you need to watch your expansion. And also when you're shutting down, or if you're emitting steam to a warm turbine, you can cool the rotor faster than the casing. So you need to watch the expansions. We're still coming up on speed. I'm going to go ahead and start the feeder on A pulverizer. Open the coal outlet. Open coal inlet. Okay. The speed overshot a little bit. That's kind of normal. You'll bring it under control. The plan is to get a pulverizer online and running so the pressure starts coming up right when we go online. Usually you'll have a startup time. It'll give you a day and an hour, usually around midnight, or hour ending 1 o'clock, 0100. So it takes about 48 hours to start the plant up, so you have to kind of plan each sequence so that you're ready to close the breaker right around midnight, 2 days down the road. It gets to be kind of a balancing act. Okay, we've got the start ready on the feeder. We're going to feed 20,000 pounds of coal an hour into the pulverizer. It'll take about 5 minutes for this fuel input to start showing up. Let's just have our main flames, have flame scanners showing low flame. That's the coal starting to go in. Let's look at the main flame scanners now. Okay, we'll go ahead and get ready to synchronize the generator. You have to go to the voltage control screen. We're going to start up the static exciter. I have to close the static exciter breaker. This is 7,200 volt. Transformer drops it down to feed the exciter. Pretty much all the motors are 7,200 volt. We're going to turn the sync scope on. This will allow us to use the synchroscope and also adjust the voltage, incoming voltage versus running voltage. This would be the voltage coming out of the generator. In real life, it's about 24,000 volts. It's going to a potential transformer that drops down the voltage to safe levels to read it. So even though it looks like a small amount, it is quite a voltage mismatch. I'm going to put the voltage regulator in manual. You don't want to leave it in manual. This would be how you adjust VARs with your exciter voltage adjuster once you close the breaker. This plant, once you close the breaker, it's going to run at 3,600 RPM or whatever the line frequency is. So if you go in at a higher speed, it'll instantaneously go to 36, which can be catastrophic. Especially if you try and going out of phase, it could tear the generator apart. So we're going to try and match the voltage a little closer. Starting to see some change now on the exciter voltage. It should be showing up. Okay, there goes the voltage up. It's a little slow in responding, but try and get it fairly close. Frequency 60, that's good. Hydrogen temperature, hydrogen pressure is 59 psi. Exciter's putting out 178 volts, almost 2,400 amps right now. Okay, we're going back to the turbine control screen. All the valve positions. Okay, our sync speed adjust. That's showing it's in service. We're basically going to raise the speed. This allows you to move the RPM in 1 RPM increments. If your pressure's coming up, it can be fairly hard to hang on to the turbine. It's going to try and speed up on you. For much over 3,600, it won't not allow the generator breaker to close if you're out of phase. The system is going to arm the generator breaker. First we have to arm the generator breaker, gives it permissive to close. Speed's a little fast, but you want about a 15-second clock in the fast direction on the sync scope. Then you want to close in so the breaker closes right at 12 o'clock. Right now we armed it. It should go 2 sweeps. Get our speed set a little better, and then we'll go ahead and close it. Once we close, we're going to have to run this and grab 16 megawatts pretty fast. So we'll type in a really high number, megawatt number, and then the rate that it's going there to get, then we'll hit the hold as soon as we get there. Pressure's coming up pretty good. One more sweep on the sync scope, and then we're going to close it. Try and load the generator up. I got 2 minutes to get above 16 megawatts, or it'll trip it. Okay, he's going to try to close it in. Got it. We're going to go to type in 450, probably 250. These are excessive numbers, but we'll hit hold as soon as we get close. We got 11 megawatts, 12. This is going to drop the drum level. We'll have to watch the feed water. Drum level is coming up because the pressure is dropping right now. It's called swell. It's going to go the other way real quick. Our alarm has cleared. This one right here, once this clears, you're good. If this doesn't clear, it'll trip the unit off. Overshot just a little bit. We'll have to hold here 30 minutes. If the pressure and temperature changes, every degree the temperature changes, we'll have to hold 3 minutes. There's charts we can use to figure out exactly the hold time, but most times it's easier just to use the 30 minutes and then any change in temperature. After the 30-minute hold's done, we can go up to probably full load. Usually run full load just after we start up. At this point, we're going to change the lube oil pumps. Right now we're running on the electric pumps. It's electric bearing oil pump, electric seal oil pump. There is a pump on the end of the turbine. The discharge from this goes down to an eductor, called an ejector. This takes a high pressure oil and produces a large volume low pressure oil. Part of this oil goes to the seal oil, the overspeed, mechanical overspeed, and also is used to push oil back up into the pump. This sits up on the second floor. This is on the ground floor. You always want to make sure all your pumps are in auto. Stop it and put it to auto. It's critical to have your oil pumps so they auto start. This is the DC. Bearing oil pump runs 250 volts DC. In case you lose your AC power plant goes black, this will keep lube oil on to get the turbine stopped. Probably still get a lot of bearing damage from all the heat in the shaft. Okay, our pumps are swapped. Now we're running strictly on the shaft pump. If the pressure drops, these will auto start. This is feeding the seal oil system. And this is your main bearings. Lube oil coolers, doing about 110, 115. These are the lift pumps. Yeah, I want to make sure those are all in auto. What these do when the unit slows down, they'll come on and keep the bearing from rubbing the shaft ring on the bearings. This is high pressure oil and it floats the shaft on the bearings. Also want to make sure the turning gear is in auto. It has to come down to a complete stop, then the turning gear will start. This one has a plate with holes in it, and there's little oil jets that go through it. And if the shaft's moving, you'll read your back pressure. And once the shaft stops, the pressure decreases, then it'll get permissive to start the turning gear. It's critical to have these on turning gear when they come down. On this unit, you can manually engage it. If the electric motor won't run, there is a socket on the back. You can use a large air wrench and turn it over 180 degrees about every 15-20 minutes just to keep the rotor from bowing. This whole thing's about 120 feet long. Fairly large shaft. We're going to close the turbine steam drain valves. These were opened to warm up the steam lines and get rid of pressure in the boiler. You control the temperature in the boiler with how hard you're firing, and the pressure is controlled by how much steam you're getting rid of. These are the turbine ventilator valves. These are used during shutdown. They'll dump steam out of the high pressure turbine, so as it's coasting down, the blades aren't trying to compress steam, producing friction, a lot of heat. These are all the drain valves. They'll stay open till 60 megawatts. Most of them will close. 120 megawatts, the rest will close. You just don't want any water getting back into the unit. At this point, we got our reheat damper is still closed. This was closed during startup because there's no steam flow in the reheater. So it's just trying to minimize damage to the tubes. We're going to put this back in auto with a set point of 1005 degrees. The piping in this runs 1005 is the 2 1/4 chrome, about the highest temperature you can go. So we're going to start running a reheat on it. The back of the furnace has two passes. One's the primary superheat, upper economizer, and the other one's the reheater section. You get a lot more efficiency out of boilers by using reheaters and feed water heaters. Basically, their boiler pressure is dropping. I'll have to put more fuel on it. Takes a minute for the dampers. They'll swap positions and try and control temperature. 5. As long as we're close at this point, a little under, we can adjust that later. Superheat sprays, make sure they're all in auto mode. 805 is a little low. We'll adjust those once we get going. The finishing superheat sprays are in auto. We're going to put more fuel on the pulverizers. Usually go about 5 clicks, about 5,000 pounds. The drum level looks pretty good so far. The big thing now is just try and hold this pressure temperature for about a half hour. Put a little bit more on E pulverizer. These are two of the bottom burners, so you have a lot more pressure, there's a lot more water wall that you can heat up. The upper burners put more heat across the furnace, more for superheating. There's a slight difference of what pulverizers you use on the boiler to produce pressure and temperature. Boil the water. We got the Economizer Recirc valves. These allow water to circulate through the lower economizer, basically through the economizer's startup to keep them from forming steam. Kind of natural circulation. And we still have the division wall drains open. These keep steam flow through the division walls to keep from doing damage to tubes. Anytime you're heating up metal, steam is used as a coolant in boilers. At this point, we're kind of in a hold pattern. We'll check out the feed water. So a level control valve, plenty of pressure across it. It's controlling level. It's got one feed pump, steam turbine running, 2900 RPM. It's in manual. And at this point, we'll just try and get the pressure settled and the temperatures, and basically soak it, heats up the metal, allows everything to kind of go to equilibrium. Just some of the metal temperatures on it. Like the blade ring, hood sprays are off. Steam chest, the deep and shallow temperatures are pretty close. Oh, look at that. Vibrations look pretty good. Rotor position looks good so far. At this point we're online. We're running the DH control, putting out 23 megawatts. And we're in a holding pattern for a little bit. That's pretty much how you go from valve transfer to online on this unit. Most generators you have to balance the voltage, get the frequency, speed set, then get the sync scope at a clock that's moving about 15 seconds of sweep, then close in. There's a lot of interlocks nowadays. You cannot close your breaker if conditions aren't perfect. And most plants nowadays auto sync. You don't even have to throw the switch anymore to close the breaker. But governor valve is 20% open. Temperature should be equalizing, warming up. And that's the generator quick overview of valve transfer and syncing online.